That's right. So the spine, spinal injury in particular, is pretty difficult to study, in part because of those pesky vertebrae that cover the spine, that prevent access to electrodes, that prevent optical access, so you can't look at things using an optical microscope. And our tools, again, could potentially be useful for that. The goal of performing diagnosis non-invasively, of course, is something that's really pervasive throughout medicine. And there are certain parts of the body where we're fortunate enough to have, pretty effective ways to look already, for instance, using ultrasound to look in the womb. But many parts of our body are covered with, these kind of, difficult structures like bones that get in the way of easy diagnosis, and that's where truly non-invasive imaging using tools like ours can really make a difference potentially. The technology that we work on in my lab is pretty basic. Soup to nuts is a word that's sometimes used. I'm not sure whether nuts are really where things end up, but we work on things that are probably ahead of the curve in many, from many medical standpoints. But I think as our work progresses and the work of the field, many of the problems that have historically stood in the way of the kinds of sort of non-invasive measurements that we want to make, those problems are getting addressed. Examples are, of course, the development of the imaging probes themselves, and that's where we've made the greatest effort, but also the development of tools for delivering these molecules into intact bodies for understanding what they do there, and so on. And so the kinds of sort of real-world applications that I see for our probes are mainly in diagnostic medicine. Our techniques are built around molecules that are a little bit like drugs, but of course they're meant for diagnosis. They're meant for in situ diagnosis. So in other words, they're molecules that somebody would have to get injected, potentially drink, and that would go somewhere in the body and tell a doctor, what's going on and what to do about it. The industries that that support that kind of work are the industries that produce diagnostic drugs, and there are many famous diagnostic drugs. For instance, MRI contrast agents. The MRI equivalent of dye that we work with kind of fancy contrast agents. They're used in about 30% of all MRI scans, so they're very widely used. Most of the clinically approved agents that are produced by companies are just sort of lighting up some structure in the body. They're not really giving a dynamic signature. But I think the kinds of companies that develop these drugs, that develop these diagnostics, could potentially be the ones that would help us explore commercial applications of our technology as well.